everyone. We're going to work through an example of using law of cosines on a side-side-side triangle. So I've got a triangle with known side lengths 10 and 14, and then I need 23 in between them, which is almost the sum of 10 and 14. So I'm going to make this pretty skinny one. 14, 23. Okay, so this is a side-side-side triangle. Side-side-side does uniquely determine a triangle, so we should be able to solve. And what law of cosines will do is allow us to solve for whichever angle we want. So this is gamma, this is beta, and this is alpha. Okay, so let's say we want to go looking for beta. I would say use the version that's got b by itself so that it'll have beta in it. So 23 squared is equal to a squared. Oh, I can do some of these in my head. 10 squared is 100 plus c squared, 14 squared. I think that's a 196, but I'm going to double check so that I don't give you a wrong answer. Yes. Minus 2ac times 140 times the cosine of beta. Okay, so there's our initial setup. And I just want to work on solving this. Let me check the 23 squared. 23 squared is 529. Okay, so I have 529 equals 296 minus 280 times cosine of beta. So it ends up being a fairly nice trig equation. So I can subtract the 296. So what are we going to get? Minus 300 would be 229. But we really only took 296, so 234, negative 280, cosine of beta. Okay, and then we would divide by negative 280. You can reduce that a little, but we're actually just going to ask our calculator for an answer in a moment. And I'm going to get that's equal to cosine beta, which means beta would be the inverse cosine of 234 over negative 280. And if we ask our calculator about that, inverse cosine of 234 over negative 280, it's about 146.69 degrees. Okay, so there's one angle. To get the other two angles, in fact, I'll do it. It's not a very long process. To get the other two angles, you could do another law of cosines, but I always think law of sines is a little bit nicer for most situations. So I'm going to do a law of sines. I'm going to say we now have one angle, so I can say sine of 146.69 degrees over 23 is equal to let's go for alpha first. Sine alpha over 10, which means sine of alpha is equal to 10 times sine of 146.69 degrees over 23. And alpha is the inverse sine, and I guess these are technically all approximate with that rounding in them, of 10 sine 146.69 degrees divided by 23. Okay, so inverse sine 10 sine 146.69 divided by 23. Sorry, I'll put that where you can see it too. Okay, so let's see, 10 sine 146.69 divided by 23. I think I got parentheses right in that. Oh, I made it angry. What did I give it? Okay, so hold on. Maybe I didn't get parentheses right. I have inverse sine of 10 times the sine of 146.69. Let me delete that parenthesis. I think that's actually extra. Okay. There we go, 13.81. Okay, which is about 13.81 degrees. That was alpha. And again, you want to do that little reasonableness check. This is a pretty big, wide, flat triangle, so I would expect alpha to be a fairly small angle, so I'm pretty happy with that. And then to find gamma, we'll just do 180 degrees minus 146.69 degrees minus 13.81 degrees. 180 minus 146.69 minus 13.81, about 19.5 degrees. 19.5 degrees. Triangle solved. All right, thanks for watching.